Hello, all. I'm Priyanka from the Department of Electronics and Communication at Sri Venkateswara College of Engineering, Bengaluru. I'm here today to give a seminar on Internet of Things and Machine Learning Model of Plant Disease Prediction, Blister Blight for Tea Plant, under the guidance of Professor Meghavashini S.K. Today's contents are introduction, motivation, methodology, objectives, literature review, results, and references. Before we get into it, let us know why disease prediction is important to us. This is important to us because if we can detect a disease early, we can start the treatment early and have a better chance of curing the disease or preventing it from getting worse. And here we are focusing on a tea plant. Tea is a very important crop that is grown in both hot and humid areas, and it is also used to make the most popular beverage in the world. However, there is a type of fungus called as a blister blight that can make it difficult to grow this healthy tea plants. This disease can cause the tea yields to be much lower, sometimes up to 40% lower than what they should be. Global climate change is making it harder for farmers to grow crops like tea because the weather is changing in ways that make it more difficult to grow healthy plants. Climate change is also making it easier for diseases to attack the crops, which can reduce the yields and the quality. Here are the few examples of the blister blight in the tea plant. Coming to the places contributing the tea growth, tea is produced in many countries, but the largest producers of tea in the world are Vietnam, China, Sri Lanka, India, and Kenya. Of these countries, China is the biggest producer of tea, making 2.5 million tons of tea every year. Here are the few largest producers of the tea in the world. Coming to the motivation, early disease prediction can help the farmers control and prevent the disease more effectively. Environmental factors and disease outbreaks are closely related, and the growth of the blister blight on the tea plants thrives in high humidity and the moderate temperatures. Early notification of the disease onset is critical for proper disease management. ML-based techniques are used to identify and forecast disease occurrences. Coming to the methodology, scientists have created a model that can predict when tea plants are at a risk of getting the blister blight disease. Using information about the environment and the plants themselves. This information can be sent to the farmers through a phone app or a website with suggestions for how to treat the plants and also prevent the disease from spreading. Farmers can also give the feedback to improve the model and prevent the disease from spreading. Farmers farmers have a very useful feedback to improve the model and the treatment suggestions over time. However, it's important to regularly update and maintain the system to make sure it's working well and using the latest information and the treatment options. As we all know, this technology helps to detect the blister blight disease in the tea plants. They have also developed a system that uses the computer program to look for the brown patches on the tea leaves and figure out whether it's caused by the blister blight or something else. The program then shows the brown patches in a different color, making it easier for the farmers to see whether it is a disease or not. This method is really fast and accurate. Coming to the hardware prototype, scientists have made a device that can measure temperature, humidity, rainfall in the crop fields in real time. This device is made using a platform called as an Arduino, which is commonly used for building IoT applications. This device uses two sensors, one to measure humidity and temperature, and another to measure how much rain falls in the field. Coming to the flow chart, we have several steps. The first step is monitoring the environmental conditions. Regular monitoring of the environmental conditions, such as temperature, humidity, and rainfall, is important to get accurate and up-to-date information about the crop field. And this is done using the sensors such as DHT22 sensor and a rain sensor, which can provide us the real-time data on the field conditions. Our next step is averaging the environmental conditions. Once the environmental data is collected, the average environmental conditions, they are calculated over a month. And this provides us reliable pictures on this overall conditions in the field. Our next step is introducing data into the machine learning model. The average environmental conditions data is then introduced to a machine learning model. This model is trained to recognize patterns and also make predictions on the input data. Our next step is prediction by the model. The machine learning model uses the environmental data to make predictions about crop growth and health. For example, it may predict whether certain crops are at the risk of developing diseases or not. And then we'll have a field observation. Once the predictions are made, the next step is to observe the field and check if the predictions are true or not. If the predictions are true and it matches with the field observation, then no action is required or none action is taken. If the predictions are not true or they do not match with the field observation, then the machine learning model, it is re-triggered to make the new predictions, which is based on the updated environmental data. This cycle continues until accurate predictions are made and appropriate action can be taken to maintain this healthy crops. Coming to the objective, it helps in detecting the blister blight in tea plants as early as possible. Early detection can help to prevent the spread of the disease to other plants and minimize the damage. To accurately identify the symptoms of the blister blight in tea plants, this will help farmers to differentiate between the different diseases and apply the correct treatment. To intervene the objective in a timely manner, farmers should be able to take preventative measures and apply fungicides or other treatments to control the spread of the disease. To reduce the objective of disease prediction for economic losses caused by the blister blight in tea plants, by detecting and treating the disease early, and farmers can also minimize the damage and increase their yield. To contribute the sustainability of tea farming by preventing the spread of the disease, farmers can reduce their reliance on chemical treatments and promote a more environmentally friendly approach to a tea production. Coming to the literature review, our first paper is by Kulkarni and team with the title Detection of Mango Plant Disease Using Machine Learning Techniques. Pros are they have a accurate detection in detecting the plant diseases and they also have a increased crop yields. Cons are initial investment and the data availability and the quality. Our next paper is by Vishnoi and team with the title A Review on Different Techniques for Plant Disease Detection from Leaf Images Using Computer Vision Approaches. Pros are they have a early disease detection as well and they also have accuracy. Cons are they have poor technical expertise and limited applicability. Our next paper is by Mendoza and team with the title Plant Disease Forecasting based on the pathogen host relationship to the environment. Pros are accurate diagnosis and they also have increased crop yields. Cons are technical expertise and the limited applicability. Our next paper is by Van Han with the title Fungal Disease Prediction based on prevailing environmental conditions. Pros are they have increased crop yields and the sustainable agriculture. Cons are limited applicability and cost. Our next paper is by Moger and team with the title Real-Time Monitoring of Plant Properties for Detection of Plant Health. The pros are they have a reduced labor cost and a sustainable agriculture. Cons are data security and limited applicability. Our next paper is by Kim and team with the title Strawberry Disease Prediction by Farm as a Service. Pros are efficient disease management and improved resource management. Cons are the initial investment and also the system complexity. Results: a machine learning model detects blister blight in tea plants by sensing environmental conditions from crop fields with regression line models, which is developed to identify the relationship between environmental conditions and the disease development rate. The IoT captures temperature, humidity, and rainfall, and the crop field data from, and it is also used for training, testing, and validation. The model predicts events with high accuracy, evaluated through field observations and enhanced by adding observation to the training data set each year. The strategy aims to enable sustainable agriculture expansion through the efficient disease management, and the model offers advantages over these traditional practices. Here are few applications. um, Early detection and prevention, precision agriculture, improved decision making, disease tracking and management, precision farming, yield optimization, resource management, risk management. Coming to the conclusions, as we all studied earlier about how how this machine learning model detects the blister blight in the tea plants by monitoring all the environmental conditions in the crop field using IoT, and it is also used for training, testing, and the validation. It gives this model gives accuracy in the evaluated field observation, and also the improved annually by adding new observations to the training data set. It helps in promoting the sustainable agriculture, and it also offers advantages over these traditional methods. Here are the few references. By concluding my paper, I'd like to say this paper is mainly uses the IoT sensors and the machine learning, which can help the farmers predict and prevent the plant diseases like blister blight in pea plants. This technology can reduce crop losses and increase profits by optimizing the use of pesticides and other chemicals. Farmers' input can improve the accuracy and the efficiency of the model, which can also be easily accessed through a smartphone or a website interface. Overall, this approach can improve the crop productivity and sustainability, especially in the tea industry where the blister blight is a major concern. Thank you.